Welcome to this video. Today we're going to see how to use some tools of OpenAir in R. Just as R, OpenAir project is an open source tool developed by the Natural Environmental Research Council that aims to provide a collection of open source tools for the analysis of air pollution data. The project is led by the University of Leeds in London. So today we're going to show you how to import data using OpenAir, create some of the graphics or charts most commonly used, and of course the installation of all the libraries. To install the libraries, you have to go to Tools, Install Packages, and here you will have to search for the OpenAir package. Once you have found it, just click it and click Install. I won't do it because I already have it in my computer, but once you do it, it will begin to download all the libraries and then install it in your computer. For this, we're going to use RStudio because it's easier to visualize all the plots and graphs that we are going to use. First of all, we're going to clear all the information in our console using these commands. This will clean the console and also clean our work environment, so we won't have troubles with previous information saved on R. Next, we're going to open the OpenAir library using this command, library OpenAir, and this will let us work in the OpenAir command sources. Now, to start importing data, we can use any of the command lines in R, like create table or table import, but OpenAir have their own function to import files, which is import. This is really useful because we already have a common pattern in our information or our data. So this just read it the way we want and it can search for the file, so we don't have to type the whole path where the file is located. For this, we are going to use the Kennedy station, which have information from air quality and meteorology variables as well. And we are going to use 1 year of information. In this case, we're going to use 2015 for all the future work we are going to show you. So now I'm going to run these lines so we can check the data we are going to import. So as you can see, he's going to ask me where is my file, where are the information. So we naming it K because the station is Kennedy, and 2015. I'm going to open, and he's going to show you this. This will create all the variables information, and here you will find your data. If you click it, you're going to see all the information we just uploaded to R. Once we import your data, we are going to use some of the OpenAir tools to analyze data. The first tool we are going to use is called Summary, or we call it Summary because it creates a summary of all the air quality and meteorology variables that we import in the previous file. So we are going to run this, and these are the outputs. So I'm going to sum them. This shows us the general information from our data. So if we saw these peaks and downs, it shows the variation of this variable. This is solar radiation. We have here precipitation, temperature, wind direction, wind speed, and on the right side we have the frequency distribution along the maximum and minimum value for every variable. This is for meteorology. We also have it for pollutants or air quality. and these red spaces show us that there is no data for that period. So this is missing data, and here it says missing, it says the total missing data for the whole year we are using. For time variation, we use the function time variation. This function shows us some plots when we can see the pollutant we want and all the temporary variation we need to see. We can choose to see annual variation, monthly variation, even hourly variation across the day. Also, you can use these commands here where only show different sections of data based on filters. For example, we are telling him that shows the wind speed greater than 3 and wind duration between 100 and 270 degrees in the pollutant PM10. This has no sense, but it's only for you to know. You can make some vectors to tell him to only use that information. So we are going to run it and you will see the result. So as I say, we have here the daily variation across all the week. So you can see how the peaks go up and down, but it almost like can connect with the previous day. You see, this is pretty good. I mean, all the data should do this. And here we have the daily average variation. So the red line is the average, and the reddish darker area beside the red is the whole variation across the week. Also, we have the different concentrations for the whole year. We can see that January, June, July, August, and December are like the lowest concentration. This also have to do with meteorology. And also the lower concentrations along the week. We have the Sundays and the Mondays. This is pretty good. It's pretty useful for analysis, also for policies that you wanna evaluate. And you can do it with almost everything. I'm just going to show you this one we made for NOx instead of PM. And you can see it's the same thing. Just the average concentration and all the variation between every month. So it's pretty useful. So now I'm going to show you how to use the windrows function and the polar plot. Windrows, well, it makes the windrows for our station or information. As you can see, we can use the whole data or we can create small data sets. For example, we are using here September for create our windrows, and also we can use the same logic with the polar plot. But with the polar plot we're going to use the whole data. So windrows shows the wind speed and wind direction in just one plot, and polar plot shows the dispersion that we are going to see. So I'm going to run bot so we can see the results. This is the polar plot. We are seeing here the measurement we're having with our station in the center. So much of the pollution is going from here or coming from here, because the colors you see, this is for CO, and we can see our windrows. It doesn't matter the time, just to show you. This is pretty useful because it's telling you that almost all the wind is coming from southeast, so it's going to north. So you can analyze all the sources and pollutants that you have in your area and all that kind of stuff. So the next function we are going to show you is a smooth trend. It shows us some tendencies in the data, and especially useful for some pollutants we're going to use. We're going to show you the tendency for NOx. So let's run it, and as you can see here, so this reddish area is where the common values for the concentration is going to be, and this is like the dispersion we are having in these special months. So we have the average for the month and the total average or the tendency we are going to have for the whole data set. We are not having information for the last 3 months of the year, but with this information we're seeing this tendency we're having here. For 27, I guess, no, 27.8, something like that, is the average concentration or the estimated concentration of NO in ppbs. Well, the next function we're going to show you is the bar plot. As the name shows, the bar plot is going to create a bar plot showing us the different variables we're going to see. We're going to show you some concentrations along the day. For that, we have to create a data set, because if we don't do it, it's going to use the whole data we uploaded and we are going to see nothing. So once you create your data set, just like we did, it's just a small vector. You're just going to run the code, and here we have, this is the SO2 concentration of ppbs. We have the concentration along the day, and we are seeing here that the biggest concentration are in the early morning and like the 8 or 7 in the morning, and then goes down. But this is a pretty useful tool to analyze some peaks and downs in the temporary behavior that we are not seeing in the temporal variation plots. Also, we can use it for different stuff, like comparing two pollutants or making it easier to see how the wind speed is going along the day. I mean, it's all dependent on you. Finally, the most useful function for policymakers is what we call calendar plot. Calendar plot is a function that we are going to show the different levels of concentration in the calendar. So I'm going to show you so it will be easier to explain it. So as we see here, we have the whole year like a calendar. The darkest or the reddish is the color. It means it has a higher concentration of PM10. This is pretty useful because we can see the tendencies in concentration for different pollutants. If we see this, we can say that the early months in the year are more polluted than the latter. So we can choose to prioritize these months to make some policies or different controls to stop the pollution in these months. So this is all for today. Thank you for watching the video. We're going to leave you the link to the OpenAir manual on their homepage, and if you have any question, just leave the comment and we will answer as soon as we can. Thank you for watching.